Welcome back everyone to the machine learning session. And in the previous session, what we have done, let's quickly recap. So in the previous session, as you can see on my screen, we have imported the libraries and this prediction is based on you can say multi-regression, basically multivariate regression. So how you are going to get started with it? We are going to keep the steps same, the major steps which we have learned in our first class, where we have done linear regression. And in linear regression, we have used only two columns in which we created our own data set. That was income prediction. Here we are going to utilize all those steps only the mathematicalization part as well as how you are going to visualize it, that is going to be changing. So let's see what we have done. Let's do a quick recap. So till now in code, what we have completed, first of all, we have imported all the libraries. And here in the libraries, first of all, we have done import pandas as PD, import seaborn as SNS, as well as we have done matplotlib to pyplot and to plot the chart. We have used sklearn model for test and train. We have used scikit-learn linear regression over here, on which we are going to run the evaluations and calculations. First of all, what we did, we have read our CSV by taking its path and we have visualized it. And after that, as you can see the visualization, when I'm going to run this code, yeah, it is going to create a heat chart. Along with that, it is going to provide us the insights below. Now, the second part which we have done, we have created two variables. One is X and Y, in which we have stored the data frames, which is like admission chances को हमने यहाँ पे drop किया है, so that we'll get the other three, four, basically six inputs we have provided. On the basis of that, admission chances were changing. Or basically, you can say we have six variables and admission chance is one variable which is dependent on those six variables. And that's why it is called multivariable. As you can see after running the code, this is how the correlation chart is created. This is the correlation on the basis of heat chart, right? We have GRE score, and these are the admission chances, TOEFL. So this last column is the important column ones, which is going to tell you which particular like GRE score, TOEFL score, or university rating, SOP, LOR, CGPA is impacting. All right. Obviously, CGPA is impacting the most. Then we have GRE score, then TOEFL, then we have SOP, university rating, in which we have removed research segment because research was 55%, which is going to deviate our, you can say, prediction accuracy. So we want greater accuracy. So therefore, after visualization, you can make changes in your data. So we have made that change. I'm going to close it. Now you can see separately, I have seen Y test as well as here is my X test, right? So all these columns, this is my X test. And I have seen, so there, here is the data evaluation, so which we have done. Now we have test and we have trained it. The next step which we are going to do now, what we will be doing, we are going to calculate the error. So after calculating the error, what exactly is the task which is left behind? We are going to run the prediction. Before that, we are going to see how much our data is being trained. So we are going to use the same phenomena that is called model fit. But before that, let me just quickly give the steps over here. The step number one, that is, you are going to type hash, and with hash, you will be typing step one. And step one is import libraries. Libraries. Step 2, read CSV. Step number 3, we are going to visualize the data. Okay, basically hash. Using heat maps. Now there is one more thing. Why these steps or these comments are important, so that anyone who is reading your code will be easily, he or she can understand. So if you are sharing your code with someone, it will be easily readable. All right. Because as of now, Python is a very familiar or user friendly language. Anyone without even coding knowledge can understand what exactly is happening. But to give it more insights, we are going to use comments. Now over here, I'm going to add external comment, that is drop y from, or you can say drop y, which is output, to get all input columns. All right. So this is one such thing which you can add upon to. Otherwise, you needed to write the entire segment, which we have like approximately 6 parameters. So instead of writing 6 parameters, why don't you drop one, so that everything which is included in that data frame is going to be calculated. So that is what we have done. So over here, we are going to run test and train. Here you are going to split the data. Step 4, splitting data into test and train. All right. And now we are going to train the data. Step 5, train the data. So now we will be starting with training the data. To train the data, what we are going to do, we are going to use model fit. And how you will be using model fit? I hope you remember our last class in which we have used model fit command. And I have explained that fit module. It's a method and it's a very, very powerful method. It's very small. However, it plays very, very important role when you are writing a code. So let's quickly use that. So we have split the data. After splitting the data, the next part which we will be doing, that is we are going to use model fit. So first of all, you are going to choose linear regression. Yeah, this is the most important segment which you have taken. So using this particular segment, we are going to create. So let's do it quickly. So we have done Y test we have written, X test we have written. Next part, okay, over here, which we are going to do, we are going to define the model, or M you are going to keep as model is equals to, you are going to call upon L is capital, linear regression, and this, yeah. So we are calling the object. So here we have created that, okay. Now model dot fit. This is the most important command, or you can say module. With this, you can see that machine is going to say that now I have understood all the parts. I have been trained. Now you can get started. Okay. So we are going to use X train and Y train, because we are training it, right? So that is what we are going to do. So this is the part which you will be doing. So here your machine is absolutely trained. So you can now run it. You can see how it is going to create. So what we are going to do, Y, basically Y capital, predict. So there will be a prediction value. Y predict is equals to model dot, and predict में हम क्या देंगे? Xtrain, Xtest. All right. And Xtest is what? All those values which we have kept, that is our Xtest. Okay. Now what you are going to do, you are going to print small test. So here you will be doing that. And now you are going to print y predict. This is what we want, right? We want the prediction of y in it. So that is the major part which you are going to run upon. So this is the part. As of now, we have not included the error consideration in it. So that is what we will be doing in short while. So meanwhile, complete this code like this. So here the prediction is going to take place. With the help of linear regression, we have done it. Now I'm going to explain to you how linear regression is going to help in this particular scenario. So I'm going to open my Microsoft Whiteboard. Basically, it's here, Microsoft Whiteboard. I don't know why it's opening there. Yeah. And I'm going to create a new one, start a blank canvas. So linear regression is what? Linear regression is basically y is equals to mx plus c, correct? This is the formula of linear regression. Now, when we talk about multiple values as input, so basically what is this? This y is basically our output. So this is your output. Output. So I'm going to just put out, and this is your angle. M is basically the angle on which the line is going to be inclined. This is your input. I'm going to write input. It's a constant value. So we are going to consider it as V. So now I'm going to write it in a manner so that you will understand. So Y is equals to, which is 1 only, right? That is our admission chances. M we are going to keep same, right? So here it is going to come mx1 plus mx2. M1 is your GRE score. M2 is, X1 is your GRE score. X2 is your TOEFL score. Again, M. X3, that is your university rating, plus M. X4, this is your SOP, LOR, M. X5, plus the last one, that is M plus MX6. And basically the next one, that is C. So this is going to be your entire formula. I hope now you have understood how linear regression is going to run the calculations at the end. So basically when you are going to complete this, it is going to be y is equals to m, and then x 1 plus and dot 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 till x5 x6 basically, and that is plus c. And now if further you are going to consider it little more, that is going to be m You are going to create a submission of X 1 till 6. So 6 values you are going to take, and then last you are going to put plus C. That is going to be your Y. So this is the calculation which this model fit is going to do at its end. And then it is going to picture the clarity, the clear picture of it, that how the calculations are running at the end. I hope now you got the clarity that Y is our output, this is admission chances, and taking all the inputs, whether that is TOEFL score, GRE score, and university rating, your SOP, your CGPA, your LOR. So all these are going to impact along with the constant, right? So once we are going to run this, that is going to calculate our Y for this particular segment. Once the Y prediction is going to be there, then we are going to find out what is the difference between the actual and the predicted value. Along with it, we will be able to find the error percentage. Considering that error percentage, then we are going to convert the error or minimize the error. Along with that, we will be running our final prediction and our model will be ready. I hope you remember all these steps which we have taken previously. It's similar to the previous one which we have completed, right? So let's quickly calculate our error, and please before that, let's quickly run this code. Everyone, step number 7, we are going to keep comparison between actual and predicted value the way we have done it previously in the previous model. So what we have done, we have taken a variable that is called comparison underscore df. This is for the comparison. We have called upon the data frame actual, which is y test, and the predicted y predict. So now we are going to see from the testing which we have kept, that is 20% testing data which we have kept, and y predict. Now what we are going to do, we are going to run both the predictions and we are going to see how is the difference. So when we are going to run it, let's quickly run it. When we are going to run, it is going to give us both the values. Okay. So let's see. All right. So here we have both the values. Yeah. Actual and predicted. So what I'm going to do, I am going to copy that. And I'm going to go to the Excel. I'm going to open a new tab and I'm going to put actual and predicted. Now, as you see that there are like certain gaps in it, right? So actual value was 94 and predicted. So basically 94 is nothing. 36, 53, 91, 93. So these are all either TOEFL score or these are inputs. So what I'm going to do, I'm going to show you some Excel tips and tricks also. So what you are going to do, you are going to go to review basically on data first, and then you are going to click on this text to column. Now you are going to delimit it. When you are going to click on next, would like to make sure that in different tabs, it is going to be separated with space, because as you can see, there are these are space separated. So 94 is there, then there is space, 0.36 is there, then there is space, and then 0.53 is there. So I'm going to click on next and finish. The moment I'm going to do that, it is going to be finished. Now, basically, I'm going to delete this particular segment. I'm taking it just to clarify, to find the error. So error, how we are going to calculate from the actual, we are going to subtract the predicted one. And then you can see here is the error. And basically, if I'm going to sum, it will give me a value which is minus 1.5. Now, this is not the correct value. So what we are going to do, we are going to run mean square or mean absolute square or mean absolute error. So these are the two things which we will be running. So let's quickly do that. All right, everyone, let's quickly evaluate the error. So what we are going to do, as we have done in the previous session, so we are going to put from sklearn dot metrics matrix. We are going to call upon import mean absolute error, and same we are going to do for mean square error. So instead of this, we are going to put mean squared error. So once we have a call upon these two, the next one, what we are going to do, we are going to go back to the code segment, and here we are going to run those. So what we will be doing, we are going to write print error, basically print error is, and then dot dot dot. And now we are going to put error is equals to mean absolute error, and that we are going to calculate from y predict with y test. All right. Now, same thing we are going to do with the square. So we are going to just put this square error is, and instead of mean error, we are going to write mean root squared. Yeah. So this is what we are going to do. Once we have done that, now we will be calculating it. So this is basically the evaluation. So you are going to write this. And now the last part, which you are going to do, square error means squared error, root squared, root means squared. All right, that is also fine. Print output is, and for that, print model dot prediction, and prediction के लिए we are going to give multiple inputs for that. So for that you are going to mention, let's TOEFL score 1500, like let's say 1500. Then the next value you are going to give, that is going to give 500. Next value you are going to give, that is going to be 400. Next value you are going to give, let's say 500 again. Next value, CGPA is going to be 8 point. That is going to be the end 1, 2, 3, 4, 300. The last one is 8.1. So this is what we are going to run. Let's see how the result is going to be. So when you are going to run that, it is going to create this chart. And over here, squared output is, squared error is. Okay. Actual and predicted value is done. Okay, everyone. So now we are going to calculate this particular segment over here. Okay, everyone. So let's quickly calculate the output. So over here till now, I have made some changes in it. So what I have done, I have import NumPy as NP as well. And here I'm going to calculate. So here MAE means mean absolute error and RMSE means root mean square error. So these are the same thing which we have done in the previous segment. Now we are going to calculate single output, single prediction. So how you are going to make that as? So let me just quickly do that. So what you are going to do, you are going to write out basically input. Okay, wait. Input. So input is going to be the values which you are going to put as an input means all those variable. For that you are going to put NumPy array and you are going to get started with, yeah, inside it, the first value you are going to put your GRE score. Let's put 337. Then I'm going to put TOEFL score, which is 118. Then I'm going to put rating out of 5 is 4, then 4.5. LOI, SOP 4.5. Then I'm going to put CGPA, which is 9.65. Means he is a good student. Once I have put that, I'm going to take output. Output is going to be model dot predict, and that is going to be my input, the input which I have put. So based on my input, model is going to predict the output. Now I am going to print what I am going to print /n, which I am going to take, that is for the line, and I'm going to put here that is output for wait, the UDMIS admission chances for this input scores is this. Yeah, I have done that. Now I'm going to print output. Print output, and it's done. So basically, this is the entire code which you are going to write. Once you are done with that, let's quickly move. Let's run. So it says that there is some error in it. No. Okay. Now over here, you can see your mean square error. That is only 4%. And 4% is actually acceptable. And root mean square error is 0.06. It means it is only 6% error. I think that is also acceptable. Now, if I'm going to move a little bit down, I'm going to scroll it a little up so that you will see the admission chances of this input score is 95%. It means he's a good student, as you can see that as per the scores which we have put over here, 9.65 is the CGPA. 337 is his GRE score, 118 is his TOEFL, and 4.5, 4.5, that is his recommendations which he has received. So he is a good student, and likewise you can put the inputs and you will get the score. So this is the prediction model which we have created on multiple inputs. So that is why it is called multivariate regression. I hope you have understood this part very